myself up there with my hey, it was the Marine Corps birthday this Wednesday as well. My dad always ingrained that in my mind that Veterans Day is also the Marine Corps' birthday. So we're in my little Lockport, military thing. Okay, so logarithms, different way of writing an exponent. Just you got to know your positions. You got to know the positions of what a logarithm is. Log base 6 of 36 equals exponent. Either know it or you don't. There is no I don't get it's in logarithms. You just got to do it. And then that's why log base 2 of 8 is 3, because 2 to the third equals 8. That's why the second one is a half. Here's the big problem with logarithms: not knowing your exponents, not knowing your exponent rules. The square root of 3 is actually 3 to the 1/2. So knowing those rules, not knowing the negative exponent rule. 5 to the negative second is 1 over 25. So that's why log base 5 of 1 over 25 is negative 2. Not knowing the zero power rule, 4 to the 0 equals 1. And then log base 7 of 7 is just 1 because 7 to the first equals 7. So knowing these is the key. All right, good. All right, we'll get that attendance here going shortly when I find a moment to do so. All right, and then I did these because there's 2 logarithms on your calculator. Log, that's log base 10. That is why log 10 is 1, because 10 to the first equals 10, knowing your logarithms. And then ln is log base e. Holy cow, did the last 2 hours get this wrong almost every time I ask. What's ln? Log base. And everyone kept saying 10. And I kept saying, I'm going to jump out the window. It's E. Log base E is ln. And make sure that doesn't happen again today, but we're going to call on you. All right. And then, so two boxes of basic properties, one in base 10 and one in base E. And by the way, you should write this down. E is approximately 2.718. It is in the line of like pi being for circles. Pi is 3.14. E is for growth and decay scenarios. It really is where that expression comes from. Like I've said all day long, though, we're not going to get to kind of do too much with E because of our not being able to delve into things as much as we have in the past because of COVID, crappy COVID year. Anyway, log base 10 of 1 is 0 because 10 to the 0 equals 1. Log base 10 of 10 equals 1 because 10 to the first equals 10. Log base 10 of 10 to the y is y. This is like this question. Log base 10 of 10 to the 21st is 21. All right, just knowing these ideas. And then ln is log base e. So log base e of e is 1. Log base e of e to any power is that power. So ln of e to the 725 equals 725. All right, just knowing how a logarithm works and blah, 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 blah. Okay, now we got a problem. And Abigail, I'm just going to have you answer some questions along. I'll make it easy. These yellows are special little rules. As a matter of fact, our book is really bad with exponents. What this says is 10 raised to the log of x. By the way, here we go. Abby, what's the base on this logarithm? Boo, it's a ghost. What is the base on that logarithm when it's missing? What is, oh no, no. Did you see me circle that? 10. So the missing base is 10. It's the default base. Now, Abby, this apparently is saying 10 raised to the log base 10 of x is equal to x. How is that possible? I don't believe in that. I'm going to put and make up a new variable, and I'm going to call it question mark. I don't believe it. We're gonna see that question mark actually ends up being x. And here's how we're going to do it. Do you know that this is an exponent? This is in exponent form. What is 10 called, Abby? Is it the base, the exponent, or the answer? What position does that play? The base. Yeah. And then what does this represent? Where is that located? Absolutely. And then what's question mark called? And then when I turn it into a logarithm, what goes down here? Which is? And then what goes here? Yeah, this is like, okay, so this is what I'm trying to figure out. What does that end up becoming? And then what goes over here by itself on the right? Yeah, the exponent. And then look at this. Let's erase the circles now. Absolutely positively, what does question mark have to equal just by matching? I mean, look at these positions. What does question mark have to equal in order for this X? There you go. That's how this ends up equaling X. Now I just proved it, okay, by just changing that exponent into a logarithm. Isn't that cool, Emily? I just see you kind of looking around your room. You got some interesting posters or something? All right. Okay. Let's get a student now. Good job, Abby. All right, can't get student number 1 there. Let's see. That'd be funny if one came up though. 7. Who is this? Where's my sheet? What am I doing? What's going on? I lost my sheet. How can I pick students when I don't have my sheet? Nadia, nice. You knew it was you. I could see you smirking. All right, could have helped me out there. Hey, what's the answer to the number 2, Nadia? Go on, and flip on that microphone. Did you say an answer? You're right. Because 6 to the 0 equals 1. You can turn off your mic now, unless you get picked again. All right. I don't know what else to tell you. Like all day long, that was kind of a struggle. I had to help people get that answer. 0. 6 to the 0 equals 1. That is why that is the answer. Oh boy. Who just got up? Who was this? Who got this one? This is a tough one. 16. Who's 16? Emily. Nice. You were looking around your room there too. Oh, I'm sorry, Emily. She looks sad. Okay, now Emily, I'll help you out here. First of all, what's 36? 6 to what power? Just tell me that first. Okay, so you end up with 1 over, and let's keep the fifth root for a second, and then this is 6 squared. Okay, then, because this is what has to happen. With logarithms, it's not the logs, it's the exponent rules. So what is this? 6 to what power? How do I get the fifth root of 6 squared into a power? Do you remember that? Yeah, so what does it become? 6 to the what power? Oh, switch it. Yeah, it is 2 over 5. And then 1 over. What kind of exponent do we have when it's, we got to, okay, so here's what I want you to do. Log base 6 of 6 to what power now? How do I flip this? What happened? All right. And then here's the big thing now. What's the answer? What do I put in that circle? You are correct. Okay, some people put 6 to the negative 2/5. No, we just want the exponent. What is the exponent on 6 that makes 6 raised to that power 1 over the fifth root of 36? So you have to do all of this. It's not logarithms, it's exponent rules. All right, and that's why students kind of fumble on logarithms because they don't know their exponent rules. And that was a tough one. So good job. You did that well. 4. Who's 4? Nice. 1, 2, 3, 4. Antonio. Yeah, good. There you are. Hey, how's your brother doing? He works for Amazon. Nice. All right. Um, what's the answer? That's a beat around the bush here. By the way, I gave you that. Boo. It's log base 10. All right. So log base 10 of 10,000. So 10 to what power equals 10,000? No, 10, oh boy, 10 to 100 power would be like ginormous. That'd be like that'd be off the charts. Hey, I'll give you a hint. That would be 1 with 100 zeros. That's what 10 to the 100. That should give you an idea. I'm going to stop writing that. That should give you an idea what power on 10 gives me 10,000. Count the zeros. 10 to the fourth equals 10,000. So the answer is 4. Okay, searching for an exponent. Good. Nice. Oh, 3. Who's 3? 1, 2, 3. Lucas. Lucas, did you get that email? Lucas? Oh, Lucas, you guys are just you guys just what do you got to do for another class? What's going on here, Chief Rooney? Oh boy, that's great. Okay, so answer this question. Boo, by the way, log base 10. Okay, so that's the base. All right. So we'll do the same thing we did with Emily. So this is a square root. What's 1,000? 10 to the what power? Okay, and then how do I write the square root of 10 to the third as a fractional exponent? So 10 to the what power? Emily had one almost exactly like this. Okay, it's a fraction. It's either 3/2 or 2/3. Got to speed this up here. Pick one. Pick the other one. 3/2. It's the power over the index. And then how do I change this to 10 to a power? What kind of exponent is this? So the old flipperoo, what kind of exponent is this? No, 10 to the what power? When I flip, what is the exponent rule? Starts with an N. Say it. Say what I just wrote there. Need you to say something here. What did I just write here? Negative. All right, come on, dude. All right, so -3/2. Okay, so then what is the power? What is this that goes in this circle, this answer here? Negative. Yep, say it. Yep, that's the power on 10 that makes this all happen. So we got to go through that progression. All right. 6K, who's that? Lucas. LN is log base what? Oh yeah, yeah. Good. It's E. Don't try to. Yeah, it's just log base E. So what does that become? What is this answer? Log base E of E to the -4th. What's the answer? It's a rule. Notice this: log base 10 of 10 to the -3/2 is just -3/2. Log base E of E raised to the -4 is log base 6 of 6 to the -2/5 is just -2/5. Log base 10 of 10 to the 4th is 4. Log base E of E to the -4th is -4. Next. Hey, nice. 4. Who's that? That's a repeat. 1, 2, 3, 4. Antonio. Oh, Antonio. Let's see if you can get this one super fast. Do you know the answer? You did good on the last one. Oh, no. Hey, LN is log base what? If you get this wrong, I'm jumping out the window. I'm done. I quit. LN is log base what? It's not 10. It's log base what? This is the third class. LN is log base E. Just say it. Come on, before I go crazy. E. Okay. And then Okay, so I was hoping you could do this because you did well on that last one. So the square root of e to the seventh, that is e to what power? This goes back to Emily's. Emily, this is killing you, isn't it? You did this, and then no one else can. I don't know why. Okay, so it's e to what power? Emily, tell him I can't do this anymore. E to the what power? 7/2. Okay, and then Antonio, how does this turn into Um, e to a power. How do I flip that? What does that do? What does the exponent become? There you go. So what is the answer to this question? There you go. Okay, and I was hoping you could do that quick so you see 7/2 and then it's a negative exponent. So -7/2 is that answer. All right. Okay, let's see who we get on this one. Oh, yes. Go ahead. No, this is the flipping right here. You don't flip the fraction, you flip the whole thing. The whole thing moves from the bottom to the top, and the exponent just turns negative. It's just like this. E to the, let's not just do e. Let's just say x. X to the negative third. That's 1 over x to the third. You don't flip the 3. That's the negative exponent rule. Okay? Cool. Excellent. Emily, who are you talking to? It sounds like you're telling secrets to somebody. Okay. All right. Hopefully it's not about me. All right. Oh, student number 1. Nice. Mayasar. Oh no. This brand new rule. It was this one. Okay, the one that I went over in yellow. Okay, and we proved it. So do you know what this answer is? 5 raised to the log base 5 of 8. Okay, let's put a question mark there. I don't get it. I don't know. I don't know what the answer is. Let's change this to a logarithm. Log, who's the base? Oh, did you answer the question? You did. It is. Okay, but I was going to have you analyze this. Log base 5 of question mark is where I have that 8 equals exponent log base 5 of 8. Question mark has to equal 8. Boom shakalaka. So what's the next one? 10 raised to the log base 10 of 14. What was that whistle? That scared me. 10, yep, log base 10 of 14. 14. And then e to the log base e of 1/5. 1/5. Just that crazy little rule that we actually analyzed and solved. All right, and then this next section I'll leave students alone. This is just calculator. You can take the log of 0.908. You will get a decimal log 0.908, and actually I think a negative. So yeah, negative 0.04. The reason is negative 0.04. 10 to what power equals 0.908? That's possible. And it's that weird negative 0.04 exponent. This is not possible. The calculator will shut down because you can't take 10 to a power and get a negative. It's not possible. So that's why that will give you an error. So will this log of 0. You can't take 10 to a power and get 0. It's not possible. Okay, so that's another time the calculator will shut down. You go ahead and press your own little buttons. ln of 0.73 does give you an answer. ln of negative does not, because you can't take e to a power and get a negative number. It's impossible. All righty. Oh, goody goody. All right, I love this. And we're only halfway through this, man or woman or whatever. Okay, so let me get a student. This is so much fun. This is going so well. Have a test scheduled today, and half the students ain't going to show up. Arr! All right, ridiculous. Okay, so who was up? I can't even. I wasn't even paying attention. Was that 11? Nice. Who's 11? Jessica Hernandez. You ready, Jessica? Okay, I guess she is. Hey, by the way, Jessica, what's the base on that logarithm? Log of x equals 4, it's missing. Boo. 10. Okay, so this is actually going to happen a lot in section 3.5 when we do solving. And we're going to see actually how this can happen. So I have log base 10 of x equals 4. Hey, just change it to an exponent. So what's the base, Jessica? What's the base? So which number represents the base in the exponential format? This is what we need. So what's the base? Is it 10, x, or 4? 10. Yeah, oh, just stick with it, ma'am. What's the exponent? This is the whole point of logarithm. If we don't know these positions in a logarithm, we're doomed. It's 4. So when I get rid of the word log, then these go in their positions. Base 10, exponent 4, and then what's the answer? Well, the answer is x. And then that goes over here on the other side. And then, of course, the answer is 10,000. So just by changing this to an exponent, I'm able to solve for this and get what x equals. And you're going to do that a lot. That's going to happen a ton of times in that section. Okay, then who? 24 is a new one. This is exciting. Joe. Hey, nice. Let's move over here. Joe, I'm going to cry if we don't get this right. ln is log base what? Yay! All right. Okay, change it to an exponent. So get rid of the word log and change it to an exponent. Who's the base? Nope. You just gave me that the base was e. So it's log base e, but it's e. And then what's the exponent? And then equals what? There you go. And then that's what x equals. The only thing, Joe, that might happen to you, e is a number, but they may put it in this format, using the negative exponent rule if it was like a multiple choice. I think I prefer that. So we know that that's going on. Nice. Okay, good. All right, that's part one. Here's part two. We're going to now graph logarithms. So you really got to switch gears because they're not really related. Although I'm going to ask you questions that make you know what a logarithm is as well. So logarithms are actually not specifically exponents. They are inverses of exponents. So I didn't have this. I had the inverse format already for an exponential, but let's just look at this real quick. Base raised to a power x equals an answer y. That is the standard exponential format. Now, when I say inverse, you say switch x and y. And that's what I originally showed you. I said b to the y equals x, and I put it in that format. So now we should know that that's the inverse of an exponential. And then to resolve for y, I need the glory and power of logarithms. Log base b of x equals y. There's the three positions switched when we change this to a logarithm. Therefore, these truly are inverses. Oh, for the love of dog, what is going on? Oh, jeez, escape. I don't know. Something got locked up in my. What is happening? I can't even escape. Control Alt Delete. I quit. Cancel. I'm back. It still didn't change anything. Let's see. Can I? Okay, good. All right. And then let's try the highlighting again. Hooray! Love this computer. These are truly inverses of each other. Okay, now, so I switched X and Y and then resolved for Y. That's what we got going on there. All right, good. So remember, for inverses, this is what happens. And you might want to sketch this down real quick because then you can understand the differences between an exponential and a logarithm graph. So here's an exponential. I'm graphing y equals 2 to the x. And I put a little chart of values over here. 2 to the 0 is 1, 0 comma 1. 2 to the first is 2. 2 to the second is 4. And then that's where this starts taking off like this. 2 to the third, 2 to the fourth, those start getting really big. Then on the other side, 2 to the negative first is a half, input output, very simple. 2 to the negative seconds, 1/4, and then that's where this gets this asymptotic behavior, getting closer and closer to y equals 0 without crossing. There's an exponential. So to graph a logarithm, do the inverse. You actually invert these coordinates. So I'm going to take these coordinates and switch x and y, and therefore that will be the graph of a logarithm. And here it is. And actually, here's both graphs, but let's focus on this black one. 2 comma 4 becomes 4 comma 2. What I'm graphing is y equals log base 2 of x. You know, the base being 2, just like the base being 2 in the exponential. 1 comma 2 becomes 2 comma 1. Here's the big kicker. 0, 1 becomes 1 comma 0. That is the numero uno, most important point in a logarithm. 1 comma 0 is the point where we want to know where that ends up when we do some shifting and so on and so forth. Negative 1 comma half is now a half comma negative 1. Negative 2 comma a fourth is now a fourth comma negative 2. And then this is what starts happening. I get closer and closer to x equals 0, not y equals 0. So a logarithm has a vertical asymptote, not a horizontal. And that's what you just got to lock in your brain, man. 1 comma 0, most important point, vertical asymptote for a logarithm. I don't know what else I can do for you. That is about as great an explanation you can get for what a logarithm is. Oh, let's do one more. Here's an exponential. Y equals half raised to the x. 0 comma 1, 1 comma half, negative 1 comma 2. Okay, so we got a little different graph there, but we still have y equals 0 for horizontal asymptote for the exponential. Now what we're going to do is invert and switch x and y. 0 comma 1 yet again becomes 1 comma 0. And this is actually the specific graph y equals log base half of x. I switch 1 comma half and I get half comma 1. I switch negative 1 comma 2 and I get 2 comma negative 1. And the graph goes like this. There was a vertical asymptote at x equals 0, not y equals 0. Okay? So that is what's going on with the logarithm. So here's where I'm going to take attendance. This is what you should have memorized. Okay, and actually, the things I hate when that happens. The things that we don't really need are irrelevant. I'm going to blank out here. There is no symmetry. There is no boundedness. There is no horizontal asymptotes, but there are vertical asymptotes. Okay, then notice the domain is not all real numbers. It is confined with 0 to infinity because of that vertical asymptote. And really what's behind it is you can't log 0. That's why x equals 0 is the starting asymptote, for the graph. Uh-oh. I had a little tickle in my nose there. Didn't want to sneeze in the microphone and scare anybody. Did I take attendance? I don't even know what the heck is going on. So we got a Lima again. I think she's missed every single Friday since September. Nice little 3-day weekends for her. Must be nice. Gabriella, when did you sneak in? Is she actually there? Skurlock's got his mouse picture back. That's good. Snyder, Sosa, Sikorovsky, Thompson, Trainer. So it just seems like Alima. Gabriella, are you there? Michael, where'd you go? All right, this is fun. I'm getting completely ignored. Okay, and then of course, we are going to shift stuff. So this is standard. This happens to every function. We could have a negative out in front, which flips it over the x-axis. You can have an a value that stretches. We're going to stay away from those. Negative on the inside is a y-axis reflection. C right, left. D up, down. Oh, I love this internet stuff. What has happened to teaching? All right, so we're going to get a student here. I think we had student 24. Oh, no, Joe, you're up. Joe? Joe? Did I just lose sound or something? I'm not really sure what's going on here. Joe? Hello, Joe. Sukarobsky, number 24. Huh? Yeah, of course he is. It's convenient. This is great. Lucas has got, what do you got, Lucas? You got a car appointment? Okay, Maya Sar, how's your connection? Nice. Hey, what's the base on this logarithm? Starting this shindig off here. Boo. It is 10. Okay, and then what does the 1 do? Is that, what's the shift on this? Good, and then what's the 2 do? All right, and then where's the asymptote? Maybe that's too early of a question, but I feel like, we have a vertical asymptote and think about what the parent is, and then we move 1 right. So where's it actually at now? And it's at x equals 1, right? And the reason is I can't plug in 1 for x. 1 minus 1 is 0, and that's what you really want to think about. The 0 in that parenthesis is bad because 10 to what power equals 0 is not possible. So that's where the asymptote actually starts. And then I'm going to ask you a question. What's f of 2? And I'm going to walk you through it. What's 2 minus 1? Oh no, what's 2 minus 1? 1. 10 to what power equals 1? Because that's what log base 10 of 1 is asking. 10 to what power equals 1? 0 plus 2 is what? Ooh, there's that whistle again. 2 comma 2. This is where 1 comma 0 ended up. 1 comma 0 for the parent function, 1 right, 2 up. Also, I love asking these questions because all you have to do is plug in. Hey, I'm going to annoy you with one more question. F of 11. Why would I do that? What's 11 minus 1? Log base 10 of 10. 10 to what power equals 10? What's the answer to that? 1 plus 2 equals what? That's the evaluation of f of 11. When I plug in 11, I get log base 10 of 10, which is 1. 1 plus 2 is 3. So 11, which is way out, this is 8, 9, 10, 11, comma 3. This is the graph. It goes like this, and then it approaches this asymptote like that. That is really your only responsibility because it's really hard to plug in any other points there. You're off the hook. All right. Unless you get picked again. Who's 27? Alima. I should give her a call right now. Hey, shouldn't I just call her on the phone? It's missing on Fridays. Bunch of blah. Ali, nice. Oh, you got your camera off. Ali, you there? We have internet connections. You getting your car fixed? What's going on? Ali, what's the domain? Oh no! Look at the picture again. We got some restrictions on X. There's things that we cannot plug in. What do I put on one there? A parenthesis or a bracket? Absolutely. Then what's the range there, Chief Rooney? You got it, Chief. Yeah, stick with it, man. Stick with it. Nice. You've done well, young Padawan. Okay, Lucas. Nice. Going back to Lucas. Oh, Lucas, I'm going to cry. LN. It's log base what? I hear bells. Log base what? LN is log base what? No. So what's the other thing that we've been mentioning all day long? That magic letter. Nope. Log base. What letter have we mentioned today that's like pi? Numerous times today. Well, actually, it's supposed to be Lucas Frank anyway. So turn off your mic, Lucas. Lucas Frank. Log base what? Help out Lucas Bukowski, huh? E. Okay, the reason I want to cover that real quick, Lucas, is ln or log base e, it actually works like this graph because b is greater than 1. E is approximately 2.718. Okay, so yeah. So let's go back down to here. What's the negative do out in front? Which axis? Yep. And then what's the 3 do? Left 3, and then what's the -4? Yeah, we can just do that. So, okay, let's analyze that negative. So I just said E looks like this, but then it gets flipped over the x-axis. So this is the expectation. It's actually going to look like that then. So we with that flippage, we're going to expect to see that. And I'll have that happen when I do some inputs here. Okay, so where's the asymptote, Lucas Frank? X equals, yeah, I thought you said negative what? 3 left, so it's at x equals negative. Yeah, did you say that first or no? It's Well, here's what happens. Here's the first one. We can't plug in -3 because that gives us 0, and ln of 0 is undefined. But we can plug in -2, and we're going to go ahead and plug that in. So what's -2 plus 3? What's ln of 1? Or e to what power equals 1? 0 minus 4 is what? That's how you do f of -2. So -2 comma -4 is where the 1 0 point goes. So it was here for the parent function, 3 left, 4 down. And that's what you want to locate, and that's what we want to know where that point is. So I need to see that in our graph. And then it's really hard to do any other evaluations with ln. And we're just going to have to show this flip. So we're just going to go ahead and graph it after that and just be done with it. Okay, let's see if we're paying attention here. Boom, shakalaka. Student number 12. Yes, I love this. Alyssa, nice. You're going to be here, right, Alyssa, for the test? Yay. Okay, what's the domain? I gave, yeah, and I already gave you the parenthesis. And then what's the range? You sound so confident. Yes. All right. Perfect. All right. Next one. Yay. Oh, I'm having a blast. Oh, Lucas, this is your unlucky day. -4 plus 2. Tell me what those are. Lucas Frank. Where is the vertical asymptote? Oh, I think nope. X equals. If you plug in 4, 4 minus 4 is 0, and that can't happen. So that's where the boundary is, where this starts. But interesting, you said 5. What is f of 5? 5 minus 4 is what? It's actually just 1. And then 1/2 to what power equals 1? 0 plus 2? 1, 2, 3, 4, 5, comma 2. There's where 1, comma 0 ends up. And I'm going to annoy you one more time. I'm going to ask you f of 8 because it does work out. 8 minus 4 is what? 1/2 to what power equals 4? That's actually doable. Think about negative exponents and stuff. 1/2 to what power equals 4? Because that's what happens when you plug in 8. You have to evaluate that logarithm. Negative what number? 2 to what power equals 4? We're overdoing it here. So 1/2 to the what power equals 4? Put it all together. -2 plus 2 is what? So when I plug in 8, I get 0, and I just wanted to show you from those 2 points, we can make a connection and understand that we have this picture. Because the base is a half, so it's supposed to look like this blue picture, which it does. Okay, the base is less than 1. There was no flipping, so we did get that classic look there from these 2 F of questions. And oh boy, we are going to ask those questions on the next test. Abso-fruitlies. I'll take care of the domain. It's 4 to infinity, and the range is negative infinity to infinity. All right. And then the last one. Who gets the last pull here? 15. Who's unlucky now? Lindsay. Yay. Okay. 2 minus x. What do you got to do about that? There you go. And then what's the base on this logarithm? It is 10, just so you know what you're supposed to be looking at here. And then this turns into x minus 2. So what are the transformations? What do we got going on here? Mm-hmm. And then what's that negative do? Nice. So we got to analyze this. Base 10 would have been the graph on the left, but when I flip it over the y-axis, then we're going to expect this picture. All right, so that's the expectation. That's what we should think about moving in on this question. Okay? All right, so going back down to there. Where's the vertical asymptote? Probably really should draw that first. Yep, it's x equals 2. And I should be writing that. I'm sorry. We should be saying x equals 2 is the vertical asymptote. And then here we're going to do f of 1. We can go back to the original and do this. What's 2 minus 1? Nope. 2 minus 1 is 1. Everyone keeps doing that all day long. 10 to what power equals 1 again? Because that's the base 10. 0 minus 1 is what? So here's where the 1, 0 point went. It got flipped over the y-axis, and then it got moved 2 right and 1 down. Well, there you go. 1 comma negative 1, input, output. I'm going to annoy you one more time. F of negative 8. Why would I pick negative 8? What's 2 minus negative 8, Lindsay? 2 minus negative 8. It's 10. We keep overdoing the negatives. All right. And then 10 to what power equals 10? 1 minus 1 is what? So -8 comma 0, and then that proves that I have this logarithm graph. It's awfully steep if that's a way I can really, yeah, it's kind of like that. All right, and then the domain. Ooh, what is the domain, Lindsay? This one's a little different. And then the 2 is a parenthesis. And then what's the range still, though? Absafruities. Okay, so hopefully you got those emails about making up the test. If you don't make up the test, I don't know what I'm going to do. I'm just going to put missing until you guys figure it out. I'm kind of getting frustrated with the having to make up these things and not getting it done in a timely manner. So I know I just offered it today, but some people are snowballing here and missing a lot of stuff. And so hope to see you then 2 or 1 o'clock. And I guess we're done. So hasta la bye bye.